Good afternoon to all that are present here. Now we are moving on to the next session. Here we have Engineer Ananth Kumar, a BE Mechanical Engineer, graduated in 1999 at Manolmani Sundarnath University, Trunelveli. He is currently working at ALBONAIR India Private Limited since 2012 as Head of the Engineering and Development Team. He has many OE customers interactions like Ashwin Leyland, Tata Motors, Tech Mahindra, Hyundai, Ford and Renault Mission, and etc. He has over 25 years of automotive experience, especially in automotive engine exhaust emission control products such as catalytic converter, catalytic integrated muffler with DOC, EPF, and CSR design. He has over the experience in Sharda Motor Industry Limited, PI Diamond Chain Limited, Reeves Cotton Limited, and Jamna Auto Industries Limited. He is currently working for Euro 7 with technology partner ALBONAIR GmbH and indigenization of after treatment electronic controllers for future emission control. He has published over 3 papers in SAE Internationals, which is related to emission control technology. One of the major contributions of him is he is one of the members of SAE India. Now I request Engineer Ananth Kumar sir to take the seat.
போறீங்க? இங்க பாருங்க, இங்க போறீங்க, உள்ள போ.
எப்படி இருக்கீங்க எல்லாரும்? தூங்குற மாதிரி இருக்கீங்க இல்லையா? சாப்பிட்டீங்களா? நிறைய செஷன்ஸ் கண்டினியூஸ் நடக்கிறதால போரிங்கா வேற இருக்கும் இல்லையா? நோ, நிறைய இந்த மாதிரி செஷன்ஸ் நாங்கள் அட்டென்ட் பண்ணதில்லை. But you people are getting a chance. I think India University is providing more opportunity to students to learn more things from the industrialists. Many ITI, IIT institutes and some entrepreneurs. I think they are providing a lot of information to you, correct? யாரும் யாருக்கும் பதில் சொல்ல மாட்டேங்கிறீங்க. நிறைய சீட்ஸ் எல்லாம் வேக்கண்டா இருக்குது. ப்ளீஸ் கம் ஃப்ரண்ட். Don't make gaps here. Please come. Students, it's your opportunity to learn. I think sometimes it may boring, but it is the future of your life. Okay? Don't take it as lazy. Sometimes many people are not able to get this opportunity, but you people are getting. Okay? Even though sometimes, see, 7 sessions you have completed, this is the last sessions. Okay? Last session. Maybe some information you may get. Okay? Okay. Thank you. Sorry for the delay, because I have some small update in my old presentation, so my laptop is not able to connect it here. So I sent it through mail. Okay. So it has been connected. Okay. So good afternoon to all. So I'm very thankful to MGR University providing me an opportunity to share my thoughts or whatever I'm learned from the industries, my experience, and whatever I've learned. So I'm also learning. Okay. I think coordinator said 25 years experience. Are you thinking that I have a 25 years experience person? I'm also a student, yeah. Till I'm a student. Okay. So I'm also learning day to day. Okay. Right. Let's go there. So I'll start my sessions. Okay. So it may not be boring, I think so. But even though it's bored, okay, please excuse. Okay. So one of my colleagues, Dr. Manikandan is here. I think he took the sessions yesterday on IoT. But this is the last, okay, but not least. Okay. So, respected Chairman of MGR University and Honorable President of MGR University, Mr. Kumar, and his Vice Chancellor, Mr. Ananth sir, and HOD of Electronics and Communication Engineering, Dr. JS Madam, and Deputy HOD, Dr. Sudhaman sir, and their supporting staffs, especially Mr. Ananth and Manikandan. And my fellow colleagues, Dr. Manikandan, Arun Kumar, and Mahendra Kumar, they put a small stall here to explain what are the products, okay, what we are manufacturing in this automotive industry, okay, how it helps to you also they may explain to you. And I think some 7 sessions has been done. The fellow guest lecturers, my sincere thanks to all. Okay. So I hope you people are well now after lunch, and this is the final session. Okay. So I've been asked to take a autonomous navigated vehicle with the smart agriculture platforms. Okay. So before that, I'm just this is code wherever I'm going, I'm always saying that. Okay. So knowing is not enough, but we must apply. Willing is not enough, we must do. So what it is called? So you are learning something in the college, correct? But you have to apply it, correct? Where? some industries or somewhere, whatever you are doing a job. Or maybe in your lecturer's college, wherever you are going to join the. At the same time, I am very much interested to join in automotive or electronic side or in IT industries or maybe a programmer or maybe a scientist, astronaut, etc. This is a willing, but how? You have to do it. In what way? You have to learn on that particular field. Okay? That's why I have placed here. First of all, you should know yourself. Okay? So, who am I? What is my talent? Okay? Then you have to explore it. So, you have to write it and then you have to study which is my best, what is my talent. Okay? Then you have to focus that what you are exploring. Okay? Then you have to take an actions. Okay? So, even though in automotive industries, these are the main cars. Okay? Then I have a small introduction about my company. Okay? Our company is ALBONAIR India Private Limited, which is an Hinduja Group company. Okay, associated with Ashok Leyland. Ashok Leyland is an automotive manufacturer. Okay? Our products are environmental solution provider. Okay? So today many IC engines, combustion engines are operating in the roads. Okay, maybe bus, trucks, cars, as well as whatever gensets, tillers, okay, cranes, etc. So we are providing an exhaust after treatment system solutions. Okay, so this is the exhaust revolution management. Okay, how it was earlier and where we are now. Okay, so in 1990 that revolution has started. Okay, BS1, BS2. Now we are in BS6 stage. Okay, now then I think BS7 will be in another 2 years. This is for automotive industry and emission and CEV as well as tractor industry. Okay, tractor means it is coming under agriculturals. Okay, so TRUM means for tractor emissions. You see here in the so in 2026, this TRUM 5, this is equivalent to BS6. Okay. So what it means, your engine is producing a harmful gases like carbon monoxide, hydrocarbons, NOx, particulate matter, methane, okay, and ethane, etc. Lot of gases are harmful gases. Okay. NOx means nitrogen oxide, nitric oxide. So now it is very harmful. I think many of the people you might be seeing in the vehicles when you are going on by riding a truck. It making a gear next level, first gear to second gear. You may see a lot of pollutions, black smokes. Okay, there is an unburned carbon. It is very harmful. Okay, so ALBONAIR is providing solutions for all automotive industries, non-automotive as well as stationary engines. Okay. Why I am saying my company? Okay, we are also a part of electronics part development. Okay, you are all electronics engineers, I hope so. Okay. So where are we? So our company, where are we? Our headquarters in Dortmund, Germany. Okay, they are the technology developers. In India, we are the applicators. Okay, I am head of engineering, and Dr. Ananth is associating with me, and Arun Kumar, Mahendra Kumar are associating with me. They are in my team. Okay, and I have a big team in this company, in my company. Okay, so another plant is in China, which is focusing the Japan, Chinese market, etc. So we are completely focusing in Indian domestic market as well as the export of Ukraine, GCC or Gulf market. So our vision is, you can see that here, everyone has to get a clean air. That means while we are breathing, there should be a clean, okay, unless otherwise you will get some issues on the lungs, okay, that will harmful to you too. Your age will be reduced, okay. So that's why we are providing a right solutions to Indian market. Our mission is also here, but you can see. So this is a general overview of this product, but same applicable for tractor industries, agriculture industries also. Okay. So this is an area dosing systems, and you can see that after treatment controller, and one of the part is ALBONAIR. Okay, we are injecting one additional liquid in the exhaust system through urea dosing, which is connected in the urea dosing systems will be a part of tank assembly, and the injection nozzle will be a part of exhaust after treatment systems. The exhaust after treatment system will be integrated with some catalyst. Okay. So when the electronic controller will provide a signal how much urea has to inject in the exhaust to reduce the NOx. So communications will be through electronics program. Then the pump is electrical part will actuate and circulate it from the tank, and the mechanical part of urea injector will be delivered into the exhaust. Okay. So you will get the nitrogen as well as water and oxygens in the exhaust. So you have a clean air. Nowadays you can see that vehicle, you cannot see the smoke. Pure air will come from the exhaust. It's maybe hot gas. Okay. So this is our general product which we are manufacturing in India, in Indian plant. So our company is a IATF certified #1 company. Okay, every year we are doing we are certified by the surveillance auditors. So this is necessary for all automotive industries. Maybe in college level you may getting an ISO 9000 certifications. That is all mandatory for college, I think so. So now I am coming for the vice systems. Okay. So you can see today the world is getting more challenges on agriculture. How? You can see that in 2005 our population is 6.7 billion, and it is expected to reach 10 billion in 2050. So increase of populations, but you have a demand of foods. So you need to develop in parallel foods. In agriculture, you have to develop more. Okay. So currently the traditional methods, wherever we are using in India, all traditional methods, okay, but it will not help to increase our demand, increase our requirement. Okay. So in this case, the smart agriculture is the right solution for in India or maybe in the world or agriculture field. So what are the challenges in the agricultural systems? We see, so the traditional methods all done by manual. Okay, you have to dig with the shovel, then plowing with the maybe with the puller cart, whatever it is. Okay, all. Then you have to know about your land how, what is the type. Sometimes it may hard or sometimes it may clay like that. Okay. Then water may not be you are not getting a right time, and polluted water as well as labors. Nowadays labors is the biggest challenge for agricultural works, as well as climate change, sudden climate change. Normally we have rainy seasons in September to December or maybe October to December, but nowadays we are getting even in May month also. So climate always changing. Okay, this is the biggest challenge for our agriculture industry. So what is smart agriculture? So currently we are using a conventional method. While we use a smart technology, maybe advanced technology, if we amend in that, that is will be a smart agriculture. Like how you have a phone, Nokia 3310, now it is coming as an iPhone smartphone or Android smartphone. So similarly, the advanced technology is also to be amended in agriculture. So the requisites already I told the 70% of food requirement has to be fulfilled in 2050. Always at the same time you have to use a proper resources like water, man as well as the pesticides. So everything will be in future it will be a demand. Okay. So you need to make it in proper way. While you are amending this or implementing the agriculture, you will get a good benefit. So important of smart agriculture, you can see here the improving productivity while you are using smart solutions in the agriculture field, your productivity will be increased. How? You can reduce your waste as well as you can provide the right product on the right time. Okay. Then you will have a cost reductions. You cannot depend on resources always. And your environmental, if you are having a IoT or AI, whatever that will drive in these cases. Okay. It will monitor the climate. According to that, it will change your systems. Then you need a sustainability solutions in future. So smart agriculture will be very much important. So the goal of smart agriculture, first one is the double the product, food product to increase by reducing the waste of 50% as well as it should not be harmful to environment. Okay. So now we are in green revolutions in India. In future it will be a technology revolutions. Okay. Here the word we cannot just farm more land. Nowadays it is very challenging because all agricultural lands are converting into residential area, institutes, industries, and many other products. Maybe it will not, but many people are selling that farmland. Why? Because they cannot able to adapt the climates or they cannot able to predict that money, okay, investment on that agriculture, everything. Okay. So the right way we have to use the intelligent solutions in the field. So the technology shift in agriculture, how it has happened is, as I already said, earlier we have a normal phone, now we have a smartphone. You can see the smartphone in the Google Map, wherever you are going, you can navigate it. In similar way, if you are adding in the agriculture, your vehicle, automatic vehicle can do everything. Okay. Smart homes now, and as well as smart healthcare industry, and you monitor your health itself with a smartwatch. Okay. So in this case, we have to go, or we have to transmit our conventional agriculture into smart. If you see that how many revolutions in the agricultural field, if you see the first revolutions will be a human dependent. Then your second revolutions will be tractors, maybe engines or vehicles has come into the field. People change, they have purchased the vehicle and they used into the field, agricultural lands to make a plowing, weeding, okay, as well as cropping, etc. Then third revolution is a smart agriculture with minimum sensors. Okay. Fourth is a completely automated. So you may have to use artificial intelligence, Internet of as well as big data analytics. You have to collect the data from the field, use it with the AI and maybe programs. Okay. robotics, drones all comes into the Revolution 4. In India, still we are in 2, but in European market or in US market and in Israel, they are already moved to agricultural 4th revolutions. So, I think you might have a sessions with all the 4, whatever the Internet of Things, sensors, actuators, artificial intelligence, big data analytics. I think these are all already covered by previous sessions. So, it may not be, again I have to take it, but all the things, even though it's an independent part, but how it has to be connected, one part that is called automated navigated vehicle. Okay. So how it will be, the automated vehicle will be what? So you have to install a lot of sensors. So the sensors will be used for soil monitoring, okay, how the soil conditions, it's then climate. So our climate will be a summer, winter, or a rainy seasons, etc. Same, you have to connectivity with the Wi-Fi's. Now in India, or everywhere you can get that internet. We are modern now. India is changing digital mode. So whatever that village, small village is also having a digital. You are getting a proper network. Okay. So in this case, the agricultural vehicles can also modify in the navigation, maybe automations. If you see in overview of that, how the automated vehicle can be connected with this, maybe it will be automated. You see lot of sensors you have to add it. Monitoring sensors, front, back, as well as many sensing technologies are among here. And you have a receiver systems because it has to connect the satellite, okay, where the data has to be transferred from the from home or office or wherever it is. Then you have a communication unit like electronic controllers. So agricultural revolution 4, you can see it will be connected to the cloud server. The centralized server will be there. All data, whatever you are taking or adding, that will be stored in the clouds and it will connect with the vehicle wherever it is running. So in current stages, we are monitoring a vehicle where it is running through a telematics. Okay. The same way, agriculture is also in change in India. Definitely it will come in another 6 years. So that is mandatory for Indian market. Okay. So these are all the certain which is mandatory for automated navigations. And how many levels we see? 5 levels are there. Okay, Revolution 4 we consider 5 levels. Without man, the vehicle can be operated. It will automatically sense where I have to go, how I have to pick it the pot or maybe the vegetables or the crops, how I have to cut it, I have to segregate it from the plant. Okay. So that level will be coming very soon. I think that when you people are growing in other companies, it will maybe you have a chance to make it. So the categories of automated navigations. One is unmanned ground vehicle. Another one is unmanned aerial vehicle. What is unmanned ground vehicles? You can see the robots on wheels, like tractors, trailers, power tillers. Okay. Those are all used for harvesting, weeding, planting, and that will be very precisely used in the field. Second one is unmanned vehicle. What it is? You can see Mainly nowadays the drones are flying in everywhere. You can see that in the marriage functions, the drones going and flying and take that everyone who are coming there, because you cannot, when you are taking a photo from here, you cannot see all the faces. The front peoples may get that, but visualize. But in drones, everybody can be captured. Similarly, in agriculture, the drones is going to use for the pesticides spray, as well as the conditions of the plants, leaves are okay. I'm just showcasing, I'm going a little bit fast, okay? So you can see that slides. I will not explain all the things, okay? But you can also surf it with the internet, the functions, how it will be, why it is used, okay? So now, the vehicle, if I am using an automated vehicle, how it has to be interfaced with the humans. First one is, it should be easy to use. In field. Second one is, it should not be discrete to the functions. Okay. So suppose weeding, if you are in harvesting, it should not damage the other fields. Okay. And it should operate automatically. Every time you should not go and monitor. But the conventional technology side, we have to monitor the persons, how much it has to be cut, how depth we have to take it, okay. But in automated, if you are making a program, how much depth, it will automatically dig it and get all the plants from the ground. And should be human centric. So there are two approaches which has been possible currently. One is the conventional vehicles, current, whatever we use, it has to be modified to the automations. Whatever the sensors, I think that means we can say retrofitments. Advantages, you can see the cost will be very less. But challenge is also there. We have a limited adaptability as well as constrained by the tractor design. The tractor cannot be able to place that sensor or cameras, we cannot be able to fix it. It is also a challenge. Okay. Second one is, it has to be started from the scratch itself, so that you can place the sensor where it has to come, where we have to place the camera, how it should be a protected one from the environmental as well as the humans or maybe in animals, whatever it has to be heated, or when it has an accident, it should not be damaged. But the thing is, the cost, the investment is huge in the new product. But once it has been implemented in the market or people's getting a hands-on experience, then it will be a cheaper to everyone. Again, the technologies, whatever we are using, the automator, it should be a precision agriculture, should be data-driven, field level, you have to manage it, as well as artificial intelligence and machine learning, and then IoT connectivity. So these all technology innovations has to be required for automated navigated vehicles. Some of the manufacturers who are in the agricultural industries, you can see CNH, John Deere, CNH, the class, they are foreign companies. They are already automated in many vehicles. Okay. But in India, it is coming very slowly. Certain places people are started to use it. It's a Revolution 3 they are using, Revolution 4 yet to come. But John Deere, CNH already implemented in Finland, Israel, US. And what about the agricultural machines? You can see that tractor is main part, and tractors and power tiller. And what kind of additional equipments has to be used? One is for cultivation, you have a separate equipment. Drill seed, you have a separate. Plowing, rotavator and sprayer, all separate equipments. It's not there using in the conventional mode. So significant use of agriculture, what you can see here. First one is this land preparations. Okay, if you see the previous things, these are the equipments, how it has been used here. So first, land preparation is important. Sowing and planting. Maybe the seed will be used. Weed and pest controls, the cultivator and sprayers. Okay. And fertilizers for spreads, irrigations. Pumps, the water pumps are used, and sprinklers. Harvesting, you have a combined harvester. And transports, the trailer will be used connected with the tractors, and it is taking your plants or whatever the crops you are cutting and getting into the field. So there are two types of sensors being used in the automated vehicles. One is the internal sensors as well as external sensors. So internal sensors are connected inside the vehicles. Okay, maybe engine speed, accelerations, torque. Connected the vehicles internally. And the external sensor, if you see here, the camera, ultrasonic sensors, and visual sensors, IR detectors, RFID. So those are all connected with the external. These will be directly connected to the electronic controller. So whatever the controller having a PCB microprocessor if you are programmed, so all the sensing will be the signals will be transferred to the controller, and controller will give the signal to the vehicle how to move it, how to activate it. So smart land preparations part. So I have shown you the significant users. So the same now everything is in automated conditions. Okay. So you can use the system. Maybe you have a tab and you can monitor how the vehicle is being plowing in the field, maybe in the farmland. So 24/7 you can operate it freely, and it will not be any fatigue to the operator, whoever is using, and you can save some times. Okay. And some sowing and planting with the precision seedles, all sensor connectors, how much depth you can load it in the seed and just activate it. It will place the where it has to place, how much depth, how much gap between the seeds. Okay. All will be programmed and automatically it will place it. So here you can see the waste can be eliminated. Okay. So sometimes while we are spraying with the manual mode, so many things can be went off. But here the machine can place it in the right place, right locations, right depth, and right gap. So it will not be taken by your birds also. Again, this pest control. Now manual mode, you can spray that pesticides, but here if you are using the drones, it can be, you can operate with a laptop or whatever that mobiles. So it can be spray very smartly how much quantity has to be injected or sprayed in each area, according to the plant's requirement. So it will sense it and spray it. So you can reduce most pesticide wastage, and cost is also you can save it. Again, this combined harvester, you can see here, you cannot wait for laborers arrival and they have to get into that land, cut it, etc. It will be again a time delay. But when you are operating a harvester digital mode, it will all cut it and it will separate that body as well as that wastage. Okay? And that vehicle is also automated. Automatically it will transfer the waste into the vehicles, trailers. So you can easily and very smartly and very low time, maybe less time, you can do all the actions. As well as that smart trailers. Okay. So without that, it can take it everything and send it to the right locations. So now the key challenges in India, we see, one is that all farmers dependence on monsoons. And learned every year in India only 2 or 3 acres will be given, but in foreign countries it will be 500 acres or 2,000 acres like that. That is one challenge. And slow technology adaptations, imbalanced fertilizers, inadequate cold storage. Maybe the tomato, whatever the potatoes, onions. You don't have good equipment here, storage equipments. Sometimes the monsoons, it getting damaged and you have to throw it everything. So wastages are happening here. And I have some solutions. The precision agriculture will be a right solutions. In small agriculture, while we implementing in India, initially the cost will be high, as well as technology dependency always required. But in Indian farmers, many farmers are not in high qualifications, so technology has to be learned more. And whatever the data, if you are using or the cloud server, how much it will be saved, securable, that we will also not know. Then skill gap. Then drone limitations also. Drone, you cannot fly more area coverage is also one of the challenge here. And our regulatory norms. In India, the regulatory norms is also not able to transfer that forward. That is the biggest challenge. Okay. And people should not able interest to learn the new things. Maybe as people we learn, then maybe in future we may amend it. The next generation may possible to amend in the new technologies. So you can see here the law in ancient days how it will be and in the nowadays. Nowadays means it is in foreign countries. Very soon in India it will be expected. And some areas we use these weeding machines also, but with man support, in future it may not be with man. So some of the videos I have, but I think I don't have, we have a very limited time. Okay. So you can see some of the machines which has been automated in the harvesting industry, weeding industry, and maybe picking that product. Okay. So you can see that I will share that presentation to HODs, maybe they can present to you. So I have a lot of videos here, maybe the smart farming, how it is in Israel. The first one video maybe. Okay, there is a file missing in that system. Okay, the source ID is not available. Maybe. So, audio is not able to connect. Okay. You can see here how the cabbage has been planted as well as crop. Okay, it's cutting how it has been harvested from the field. There are no man interventions in the equipment machines. All automated. Everything will be connected through artificial intelligence, data science, IoT, and all sensors connected through the program. It is all programmed in the electronic controller. This is for reading. Okay, it's sensing that the laser is passing the laser rays and reading that whatever the unwanted plants. So if you see that in the audio, he has 15,000 acres of land and all planted with the cabbage. So how he can harvest it? Resources we are placing means how many days. So he used that machine. So he can quickly getting the capitalizes from the learned and transfer into market. Limited resource can be used here. So how robotics used to pick the strawberry plants? So you have a tender strawberry as well as this good fruit strawberry. Okay. So it is sensing it and picking the right fruit and place it into the packet. How these robots are working with electronics? Mechanical machine, electrically program, and it will be picking that product. So again, drones, how it is being used to spray the pesticides. In foreign countries, many farmers are educated people and they have more land areas. Okay, but in India it is very size is very low or less, but can be used. But investment can be maybe tractors one person can be purchased and it can be horizontally deployed to other farmers also with a lesser cost. So nowadays it is happened the same way in future. This will be a possible one. Okay, I think so. I have run more than 59 slides. Okay, but sometimes it may be I have run through fast, but at the same time, the time constraints also there. I have shown some videos, and maybe you can surf it in that website. You may get more details. Okay, and that will be used in your future career development. Okay. Thanks a lot. Thanks for the time. Thanks for your attention.
Thank you, sir, for such an insightful lecture. I now request our HOD, Deputy HOD, moving on, I now request our DPMD, Deputy HOD, to felicitate our resource person. warm and respectful welcome to our chief guest, Engineer Ananth Kumar, executives, HODs, faculties, and students to this valedictory session. Today, we come together to mark the conclusion of the 2 days DST-SERB sponsored National Level Symposium on Smart Agriculture, organized by Center of Excellence in Smart Agriculture, Department of ECE. A report is not just a record of what happened, but a reflection of the collective effort, experiences, achievements of the event as the event leaves behind memories and milestones. So I now request Dr. K. Sujata, Professor Tripoli, to present the report of the NSSA.
So very good evening to everyone present here. I hereby take this opportunity to summarize the activities of the symposium carried out for the last 2 days. The Department of Electronics and Communication Engineering organized the DST-SERB sponsored National Level Symposium on Smart Agriculture under the Center of Excellence in Smart Agriculture on 10th and 11th September 2025 at Dr. MGR Educational Research Institute. The event comprised 4 sessions on the first day, and it began with Dr. U. Jayalakshmi, head of the department ECE, who delivered the welcome address and enriched the gathering with her valuable thoughts. This was followed by Dr. K. Sujata, professor, who shared her insights about the symposium, and Dr. N. Etiraj, Dean ENT, who provided an overview of the event. Dr. Cyril Raj, additional register, then delivered the keynote address, offering a comprehensive perspective on the symposium theme. Subsequently, Dr. Swapna, Associate Professor ECE, introduced the chief guest, after which Dr. J. Praveen, Senior Scientist from CSIR, was felicitated and delivered the inaugural address, sharing his expert vision on the future of smart agriculture. The first day of the National Level Symposium on Smart Agriculture provided a comprehensive journey for foundational theory to practical applications. The session began with a deep dive into artificial intelligence and computing by Dr. J. Praveen, Senior Scientist from CSIR, who detailed the power of convolutional neural networks for achieving translational invariance tasks. Coming to the next speaker, Dr. Ganesh Kehre, Associate Professor VIT, introduced precision agriculture, outlining how AI-powered robotics and IoT enhanced efficiency and how advanced techniques like GAN can solve data challenges. He culminated his talk with a forward-looking vision for proactive, data-driven climate-smart agriculture. The focus was then. Next we have Dr. Manigandan, Manager at ALBONAIR India Private Limited, Chennai, offering industry perspective on creating intelligent farming vehicles for precision tasks. Finally, the first day ended with Dr. V. Vinod, Associate Professor, VIT, who provided a lecture on complete academic framework for agricultural IoT systems, from sensors to cloud analytics, addressing the key challenges like rural connectivity and power management, and completing the day's narrative from core principles to real-world implementation. Coming to the second day of the session, the symposium commenced on 11/9/2025. The first speaker of the second day was Dr. N. Papa, Professor, Instrumentation Department, MIT. Her lecture covered the key aspects wherein she started with the introduction to conventional neural networks and progress to deep learning neural networks. Her lecture also gave insights about implementing various architectures for agriculture. The second session today was delivered by Dr. Shaktivel, Professor, School of Mechanical Engineering, VIT. In his lecture, he discussed about agrobots, plant disease detection, multi-crop harvesting, missions, agri-robots, vision-based laser weeding mission, autonomous tomato harvester, drone-based apple harvesting, and so on. The third session was presided by Dr. Chitrakala, Professor, CSE, Anna University. Her lecture was titled Generative AI in Smart Agriculture. She discussed about discriminative versus the generative AI modeling, then introduction to generative AI, power of generative models, functions and so case studies. Her lecture was interesting. Finally, we have engineer Ananth sir, GM from ALBONAIR India Private Limited, who discussed about autonomous navigation, navigating vehicles for smart agriculture. His lecture was informative. On both the days, we had paper presentation sessions. Nearly 43 papers were received from various engineering colleges based on the theme of smart agriculture. The participants shared their views on smart agriculture. On the whole, we had an overwhelming response for these 2 days. Finally, the program ended with the valedictory function convened by convened by Engineer Ananth sir, GM ALBONAIR India Private Limited. Thank you.
Thank you, ma'am. Moving on, now I request all the dignitaries to felicitate our chief guest, Engineer Ananth sir. Thank you. To conclude this remarkable event, I now request Deputy HOD ECE Dr. E. Sudhaman to deliver the vote of thanks.
Good evening. On behalf of the Department of Electronics and Communication Engineering and the Center of Excellence in Smart Agriculture, I convey my heartfelt gratitude to everyone who have made this DST-SERB sponsored National Symposium on Smart Agriculture with a good success. We are deeply honored for the support of our Honorable President, Engineer A.C. Kumar, who is our motivation and constant support for all our endeavors. Sincerely thank our chief guest for the day, Engineer Ananth Kumar, General Manager, Development, ALBONAIR India Private Limited, who has consented to be our valedictory guest. He has also given us talk on delivering the valedictory address. So we are also grateful to our Vice Chancellor, Registrar, Deans, Additional Registrar, Joint Registrars, HODs, staff members and students of our department for the enriching knowledge that has been shared on smart agriculture and its technological advancements for past 2 days. Also thank our committee members, our head of the department, Dinesh Vinay, and all the staff members and students for this 2-day event. Thank you all.
Thank you, sir. Now I request final year ECE A section students to gather near the stage for the group photo.
A section students, come. Staff members and A section students.
अरे
Get to the stage.
live will come.
भारत जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाहे